Students, listen. Today we are going to see the multiplexer. Here multiplexer means many into one. A digital multiplexer is a combinational circuit that selects binary information from one of the several input lines and direct it to the one output line for transmission to a common destination. The selection of a particular input line is controlled by a set of selection line, that is the data select. Okay, the multiplexer has several input lines and a single output line. It also has data select input that helps to choose any one of the inputs to be switched or that is connected to the output line. The logic symbol for a 4 input, that is a 4-to-1 multiplexer, is shown in the figure. Here is the figure. Here there is a 4 data input lines, that is D0, D1, D2 and D3, and we have the data selects, that is S1 and S0, and we have one output line. So here we are having 4 inputs and having only one output, so it's known as many into one. So many inputs and having this this is having many inputs and having only one output. Okay, so now here is the a tabulation for the selection lines. Here we are having S1, S0, that is the data select or the control lines, and this is for what? To select the particular data input line. For that only we are having. So for this we are here we are having 4 input lines. So we have 2 data select, that is S1 and S0. Here is the combination for that. We are having 0 0 0 1 1 0 and 1 1. If the data select is S1 is 0 and S0 is 0, means the connection to output Y is given to D0. Like that, S1 is 0 and S0 is 1, then the connection to output will of Y will be D1. If S1 is 1 and S0 is 0, means connection to output Y is given by D2. Like that, S1 and S0 is equal to 1, then the connection to output Y is given to D3. So now thus it is found that the data output, the data's output Y is equal to the data input D0 if and only if S1 is equal to 0 and S0 is equal to 0. So therefore Y is equal to D0, S1 bar and S bar. Data output is equal to D1 only if S1 is equal to 0 and S0 is equal to 1. So that is Y is equal to D1, S1 bar, S0. Like that, the data output is equal to D2 if and only if S1 is equal to 1 and S0 is equal to 0. So therefore Y is equal to D2, S1, S0 bar. The data output is equal to D3 if and only if S1 is equal to 1 and S0 is equal to 1, that is Y is equal to D3, S1, S0. The logic expression for the data output is obtained by using OR gate, that is ORing the above possible combinations. Therefore we have Y is equal to D0 S1 bar S0 bar plus D1 is equal to plus D1 S1 bar S0 plus D2 S1 S0 bar plus D3 S1 S0. The above logic equation can be implemented by using 2 inverters, 4 3-input AND gates and 1 4-input OR gate as shown in the figure. The circuit is also known as data selector, since data can be selected from any one of the input lines. So here we are having for to draw the logic gate for this, we need once again I am saying 2 inverters, 4 3-input AND gate and 1 4-input OR gate. So for on behalf of this, we can draw one diagram for this, that is 4-to-1 multiplexer. So by using 2 inverters, listen, by using 2 inverters are here and 4 3-input AND gates and 1 4 input OR gate here we have used to draw the 4 to 1 multiplexer. So from this we have drawn the 4 input to 1 output multiplexer. So see, here we are having the inverter, 2 inverters, and yeah, here we are having 4 AND gates which are having 3 input AND gates and 1 OR gate using 4 input. Okay, so by using this we have drawn the multiplexer. The circuit can be expanded to include more input lines with one data select line, that is 2 to the power of n input lines can be connected to the single output in a multiplexer. Okay, thank you.